Hello, ladies and gentlemen. It's about 4:30. I apologize that this will be coming a little late in the evening. However, this is for you. There's been a number of you that have come to see me during the day with some very elementary questions and some more complex questions about what the heck it is that we've really been doing over the past 3 lessons. So I thought that we would do a very quick Mr. White's review of calculus so far. And I'm not going to want this to get too long, so I'll probably work for a little bit and then stop and upload and then go on from there. But let's see what happens here. So let's see. Let's start with a concept. One of our concepts here is that we can come up with slope, average rate of change, will give us the slope of a secant will be delta y over delta x. And another way to write that would be y2 minus y1 over x2 minus x1. So, and what that's talking about is if we have a function, and if that function does something, okay, if we wanted the average rate of change between this point, x sub 1, and this point, x sub 2, okay, 2 different places, notice that they have corresponding y sub 1s and corresponding y sub 2s, that the average rate of change could be determined by the slope of that secant. And by definition, a secant is a line that will cross the curve at 2 points. So we talked about this a little bit, and that would be your average rate of change. Now, it doesn't tell us a whole bunch. It's not really great, but roughly, between this point and this point, we have a change that's equal to this slope. We did some notation changing. And the notation we decided to make this x, and we decided to make this x plus h, which meant that that distance here was h. We decided that this would be f of x, and we decided that this would be f of x plus h. Okay, so these are just a change in notation. And so when we did this, we came up with f of x plus h minus f of x over top of x plus h minus x, which gave us the new notation, and we call that the difference quotient. The difference quotient because it's a difference, quotient because it is division. And what that is the average rate of change between any 2 points, but given a specific point to start with. I can't spell. Specific x value to start with, and a specific distance. H to the next point. And that was about it. And what we did was we formalized that for any particular function. So the f of x was meant to represent any single function. So we could go through and determine the slope of the secant for any function given a point and a specific distance to the next point. So let's start with the function f of x equals, how about x squared plus x, just for fun. Okay, and let's say that we want to come up with a simplified form of the difference quotient. So the difference quotient is given by a formula. It is f of x plus h minus f of x over top of h. That is the difference quotient. There's no talking about it. There's no discussing it. We built it up here. That's what it is. So over here we know that f of x is equal to x squared plus x. You know that f of x plus h is equal to x plus h squared plus x plus h. And so that will expand and we'll get different things. So anyway, what's going to happen here is x plus h squared plus x plus h, subtract f of x, which is x squared plus x. You better remember your brackets. And we're going to put that all over top of h. You can work this out. What it'll give you is it'll give you some sort of equation in terms of x and h, and you would then simplify. So there's more to do here. But remember, I'm just doing a review of the concepts. There you go. There is the difference quotient, which is the slope of the secant.